Okay, so in this section, we're going to talk about square roots. Um, in the upcoming sections, I should say, in chapter 5. So we're going to do 2 days on remembering how to simplify radicals because we're going to use this skill in those lessons in our book. So we're going to start out with the very basics here of simplifying radicals so that we can actually figure out what's going on when we're taking the square root of something. Because what we're going to do is we're going to be simplifying radicals so that we don't get a decimal answer. Okay. So looking at this, when we look at all of these over here, we get integer answers for all of these, right? You can square root all of these numbers. Okay. So let's actually look at what's happening when we square root. So if we look at the prime factorization of each of these numbers, which means, if you remember, we took our calculators and we were just dividing by first what number? See if we could divide by 2 and then 3 and then 5. So can we divide this by 2? Nope. Okay, so what we're going to do is, you could also do a factor tree. Okay, so you could figure out what the factors are, 9 and 9, and then keep breaking it up. Or use this calculator shortcut where you're just dividing your number. So if we take 81 divided by 3, can we divide the next number by 3? 27. Is that divisible by 3? Okay, we divide by 3 again. And what are you left with? 27 divided by 3? 9. Can we divide that by 3? And then you're left with 3. So if you take 3 times 3 times 3 times 3, we get 81. Okay, so what we're doing when we're square rooting something is we are looking for pairs of numbers that match. Okay, so we've got these that match and we have these that match. What we're doing is we're taking them out of the root and just writing down one of those single numbers. Okay, so right here, there's a group of 3, so we write down 3. Here's another group of 3, we write down 3, and we get 9. When we have 36, 36 we can divide by 2. So we're again going to write the prime factorization of 36. We've got 2. We can divide that one by 2. And I'll just quicken up this process here. 2 times 2 times 3 times 3 gives us 36. And we're looking for matching sets of numbers. So we've got a matching set here, matching set here. And what we're doing is we're taking those numbers out. And when you take them out, you only write one of them. Okay, so we've got this pair of 2's, take out a 2, pair of 3's, take out a 3, gives us 6. Okay, so we've got 1 times 1, which there's only one pair in here, so we take that out, we get 1. What about 16? Yep. How many 2's? Okay, so we've got this. We take those out, we've got 2 times 2, which is 4. Yes, this seems completely ridiculous to do because I know that you know that the square root of 16 is 4. But we're doing this for a reason, and I promise we'll get there. 25. 5 times 5, we've got a pair of numbers, we take that out, we get 5. Now here's why we're doing it this way. Because none of these over here will give us just a single integer answer. Okay, so over here we were getting nice clean numbers for answers. We got all these wonderful non-digit or non-decimal or fraction answers. So when we have something like this, what we're really doing is we're simplifying. Okay, we're not going to be able to take everything out of the root like we did on these first problems. So we're going to get the prime factorization for each of these. So 24. Can we divide that by 2? Okay, so we write down a 2. When we divide it by 2, can we divide that number by 2? Okay, 12 we can divide by 2. Can we divide the next number by 2? Yep. And we're left with 3. So 2 times 2 times 2 times 3 is 24. Now, we're looking for matching pairs of numbers. We have a pair of 2's right here. So what do we do with that? We take it out of the root, take it out front, which has 2 here. What's left over underneath the root? 2 times 3, which is 6. So square root of 24 is the exact same thing as 2 root 6. Okay, let's try it with 500. It might be helpful to have your calculator by you so you can practice with this prime factorization shortcut. Because all you do is you're going to take your number and you're going to start dividing by 2 as often as you can and writing down every time you do. So I'm able to divide that by 2. The next number on my calculator I can divide by 2. So I write down a 2 again. And now I have 125 on my screen. So I can't divide that by 2. Can we divide 125 by 3? What's the check? How do we check to see if it's divisible by 3? We add the digits. So 125, 1 plus 2 plus 5 is 8. Is 8 divisible by 3? No. Okay, so we can't divide it by 3, but we can divide it by 5. So now we hit divided by 5, and we write down that we divided by 5. Now I have 25 on my screen, so what do I write for that? 5 times 5. Okay, so again, we're looking for pairs of numbers. We take these out. What do we have? What do we have on the outside? Yep, 10 root 5. Okay, 108. Prime factor of 108. So we start dividing by 2 as many times as we can. Only twice, and then we hit a number that's odd. So now we start dividing by 3 until we get all the way down to the smallest number. Okay, so we look for groups of 2. And we have what? Take out the 2, take out the 3, we multiply them to get 6. We still have this 3 left over underneath the root. All right, let's talk about when we have a number out front like this. 120, let's start dividing that by 2 as many times as we can. So there's our prime factors of 120. There's only one pair of numbers that match. We take this out, what are we going to do? Times it by 5. So we really get 10 root 30. It really helps if you circle what you're taking out. That way you know exactly what's left over underneath that root still. All right, now shifting gears a little bit. Whenever we've been square rooting, do you know what number is on the outside here that we've never written? There's a little imaginary 2 that we don't ever write there. Okay, that tells you what size group you're looking for. So if we have a cube root, we're now looking for what? A group of 3 numbers that match. Okay, so that's the only thing that changes. So we've got 54. Which is 2 times 3 times 3 times 3. We do have a group of 3. Forgot to write my little 3 out here. So our answer is going to be what? 3. The cube root of 2. Yes. We have to keep that little tiny 3 out there. That doesn't disappear. Questions? We're going to try 2 more before we get to the worksheet. All right, so looking here, I'm going to give you a little bit of a head start here on these 2 problems. And then I will join in with you and we'll see if we're able to reach the same answer. So remember, you start dividing by 2 as much as you can.
I've sort of have basically this,
Yep.
this,
Yep.
this,
Yep.
this,
And then one more time.
this.
And then that's the number you write on the end. Did we get this? Okay. So we take this group right here, making this 30, and the 4th root of 52. Make sense? Okay, then we'll move over here. The cube root of 'Is that the numbers you get? Okay. So we're looking for groups of 3 on this one because it's the cube root. Taking that out would leave us with what answer? Cube root 7. We good? So the worksheet is all problems just like this.